Regarding, why don't you, I'm going to get my 3CL.
So those are the forward and back. And you guys are oh, we find the standing here. Okay. And the camera is the frame here. Yeah. I think if you do want to walk around, we all practice. Yeah, yeah. Okay. Somebody in the oh, okay. Right.
I got it. Is that okay? 4 minutes time.
Guys, you're making me remember so many things last minute. You only all really nice. I told you guys, I told me a lot of it. There it is.
starting? You are. You start. Look at the setup here. That's like a professional thing. Okay, everyone. Welcome to this second semester series of Geotalks. It's fantastic to see so many second years and some third years, and of course, mainly the honors class, because this is all about you and your experiences. So welcome everyone, and to our online audience, thank you for joining us. We have a fantastic setup here, thanks to Robin. It feels like I'm in a professional film set. So I'm glad we can stream across YouTube. So today we have a long-standing tradition in school, which is that the honors classes, both geology and geophysics, present a tour around their or a tour of their field trip that they went on earlier in the year. And it really is a very impressive field trip that goes across the Craton. So they're going to tell us more about that. And later in the year, the geophysics honors class will present. And so from this year's honors class, we have 4 presenters: Declan, Sadie, Retometsa, and Kobelo. So thank you guys for telling us about this, and we really look forward to all the interesting information about your trip, and well done to the whole class. And I think Ben has said many times that it was a really fantastic trip, and so that's largely to a really fantastic honors class. So over to you.
Thank you, Grant. Good afternoon, everyone. We are the Geology Honors Class of 2025, and we'll be presenting on the Archaean and Proterozoic Metallogenesis in South Africa, which is a field excursion we had to Barberton, Greenstone Belt, and the Bushveld complex. This is the field overview of all the sites that we visited in the yellow stars. So, and the metals we came across and studied in the field trip. So stops 1 to 3, those are in Barberton, and 4 is in Opi Plus, 5, 6, 7 are in Beggarsport, and the rest were in Limpopo. We stayed in Dibani Lodge. This were in Mokopane. Yes. So the aims and objectives of the trip was to explore and compare the Archaean, which is the Barberton Greenstone Belt, and the Proterozoic Metallogenesis, the Proterozoic being the Bushveld complex, through the visits to mines and the field geology that we did. So this was a field-based investigation of Barberton and Bushveld regions. We did this by identifying lithology, structural controls on mineralization, and textures that we came across. We used all this field data to relate it and compensate the theoretical lectures we had before the field trip. We had some light-hearted presentations throughout the field trip that were alluding to the sites that we visited. So groups A and B were presenting on the Barberton Greenstone Belt, and we had 2 presentations in the Eastern Bushveld, 1 in Marsfontein Kimberlite Pipe about diamonds, and 2 in the Northern Bushveld complex. So why did we visit the Bushveld complex and the Barberton Greenstone Belt? This is mainly because the Barberton Greenstone Belt is a well-preserved Archaean Greenstone Belt aged between 3.5 and 3.2 billion years, and the Bushveld complex is the world's largest Proterozoic layered intrusion aged at 2.05 billion years. So this is like a has global significance in crustal evolution and ore formation. The Archaean and the Proterozoic metallogenesis is rather debatable, especially the Archaean, which is plume-driven tectonics, but that is highly debatable, like I've said, because It is said to be horizontal and vertical mantle plumes. And the Proterozoic has a more stable plate tectonics with PGEs and SEDEX deposits. So these generally show a shift from in crustal processes and or environments over time. The field had a flow from looking into rocks and the structures and link that to the ores that we came across and the genetic models that we had previously learned about from literature and lectures, and we did this through ore textures, lithologies, and the structures that we came across in outcrops.
Good afternoon, everyone. I will be taking you through the Barberton Greenstone Belt part of our field trip. So we spent about 4 days in Barberton exploring the Archaean geology and mineralization processes that are associated with it. So the Barberton Greenstone Belt is an iconic, well-preserved example of Archaean terrains. It is approximately 3.5 billion years old, and the Barberton supergroup is divided into 3 main groups. The first one is the Onverwacht group, which consists of mafic, mostly mafic and ultramafic volcanic rocks, including komatiites. We've got the fig tree group, which is represented by deep water sedimentary rocks, and the Moody's group that is represented by shallow water sedimentary rocks. So the Barberton Greenstone Belt is crucial for understanding crustal evolution, Archean tectonics, as well as mineralization processes. Our first stop was the Barberton Makondwa Trail. This is a stunning 38-kilometer trail that runs from the town of Barberton to the Josefsdal border post with Eswatini. It was declared a UNESCO World Heritage Site in 2018, and it includes key outcrops such as banded iron formations, komatiites, and cherts. The trail ends with rock samples and geological information displays, and these serve as an outdoor classroom for geoscientists all over the world and the public alike. I've added a group picture of the honors class here in front of an impressive outcrop that shows folding. And this was very nice to see because it gave us insight into the scale of deformation that was happening during the Archean. Now onto the real treasure of Barberton, it's gold. Most of the gold is shear zone hosted orogenic gold. And this was the focus of the Barberton gold rush, which happened in the mid-1800s before the discovery of the Witwatersrand gold. The gold mineralization that we explored is related to quartz veins in metamorphic and igneous rocks. The orogenic gold deposits that we saw are mostly structurally controlled. So they were confined to, if you look in the geological map here, we visited Agnes, Fairview, and Sheba, and we can see that they are mostly associated with major faults and folding in the rocks. Like I mentioned, we visited Agnes, Fairview, and Edwin Bray's Golden Quarry. So this golden quarry was very rich in gold, yielding 1 million tons of ore, and the gold that was there was graded at 23 grades per ton. Our next, the 2 mines we visited, Agnes Galaxy Gold and Fairview Gold Mine, are both shear zone mesothermal gold mines, and they're, like I mentioned before, structurally controlled by major faults. One interesting takeaway that we got from Fairview Gold Mine was the fact that they're pioneers in biological oxidation process. So this is where they use trillions of cultures of bacteria to basically simply put, eat away at the sulfides that might be containing the gold, and this frees the gold and makes it easier to mine. It also contributes to the global efforts towards sustainable mining methods. And most of the mines in the Barberton area use the mining method of cut and fill, which is something that they usually use for steeply dipping ores. Our next visit was the Moody's Basal Conglomerate. So this is located in the northern margin of the Barberton Greenstone Belt, and it is a key site for studying strain in deformed clasts. A lot of people all over the world visit this site in search of the oldest granitic clast, about 3.2 billion years old, which is hosted in quartz-rich sandstones. Our next visit was the Base Annex Geoheritage and Science Outreach Center, which is in the Barberton Museum. This center basically was created to show people the different rocks that occur in the Barberton Greenstone belt, as well as help them understand why it's important to keep on studying these rocks and how they shape how we understand the Archaean. We also visited the Pioneer Complex. So there are about 27 layered mafic, ultramafic units. The Pioneer Complex is number 17, and it is attributed to intrusive emplacement or subaerial volcanic flows. So a key feature in these complexes are komatiites, which are indicators of the type of temperatures that were experienced in the Archaean.
Okay, moving on from the Barberton Greenstone belt, we made our way towards the eastern limb of the Bushveld complex. But on the bus ride there, we made 2 stops at geotourism sites. The first of which is Bork's Luck Potholes, where you see all of us are very happy to have a rest day. Yeah, we saw some fantastic sites in the red sandstones where this river eroded all these potholes. Then we moved over to the 3 rondevels where we had this lovely view of these quartzite mountains. And over here, we had a nice presentation from Group C. And just to mention, these presentations we had to do in the field. It took a lot of work, teamwork to do. So moving into the actual work that we did in the eastern limb. So we were here in the eastern limb of the Bushveld complex. And we mainly worked on the upper critical zone and the marginal zone. So starting, we walked through a river cut of the upper critical zone. Here we have our nice scale, Daniel, next to some of the feldspathic pyroxenites that we saw. As we moved down, we saw some norites and some more feldspars associated with these norites. As we moved even further down, we started to see mottled and spotted anorthosite, with this image showing the spotted anorthosite, showing the change from more mafic rocks towards felsic rocks, thus explaining fractional crystallization. And yeah, in the Brescia pipe, Leo, our lecturer, didn't seem too happy with Daniel, raised his hammer. But yeah, at the Brescia pipe, we saw a pretty large wall with these large clasts up to 30, 50 centimeters in size. These clasts consisted of anorthosite, norites, and pyroxenites, which we saw walking towards this Brescia pipe. So this Brescia pipe must have post-dated all these rocks. There was a bit of a debate as to how this formed, but the class consensus was likely overpressure, which resulted in brecciation. And these dikes we could see in every single rock as we were walking down. These dikes ranged in size from meters to centimeter scale. Then we moved over to Dwar's River Heritage Site, which exhibits the UG1 chromatites. Here we did a class exercise or group exercise, much to everybody's dismay, as we were all tired and it was very hot. But we all got through it nicely. Yeah, we also did a presentation, Group D, who did a presentation as to how these UG1s formed. So the Dwar's River is a very unique site as it shows these UG1 chromatites splitting and coming together. So in this image, we can see a thin anorthosite layer thinning between these chromatite layers, eventually forming one chromatite layer. And even further, we saw some wavy chromatite where you usually see uniform chromatites. And we also see anorthosite blocks where it appears that the chromite is almost flowing around these blocks. And this model that I think best represents the UG1 chromatites kind of encompasses how crystallization of this chromatite formed. So a magma chamber that was initially there had superheated melt that was more primitive and denser than the stratified magma from previous replenishment events. The superheated melt is super dense and causes the stratified magma to rise. The superheated melt then causes thermal and chemical erosion of the cumulate pile below. And as more replenishment is occurring, chromite saturation is occurring, resulting in chromite crystallizing in situ along this uneven plane or uneven cumulate pile, which could have resulted in the potholes or the wavy chromatites that we saw. Yeah. And then following chromite crystallization, the cumulate pile started to grow again once chromite was depleted. And our final stop in the eastern Bushveld on day 2 was at another river cut where we saw the marginal zone between the eastern limb of the Bushveld complex and Transvaal sediments. Here we saw some alteration of the rocks along with another pressure pipe. Though this pressure pipe was a bit contentious along the class as everybody had their own thoughts and ideas, and I know there are still a few that are fighting.
Thank you very much. I'll just be taking us through our venture through the northern limb of the Bushveld complex. So the northern limb is the northernmost limb, lobe of the Bushveld complex, separated from the eastern and western limbs by the Tabazimbi-Murchison lineament. So it has a generally sinuous surface expression that strikes for approximately 120 kilometers. And it is characterized by stratigraphic differences from the eastern and western limbs. These include the absence of a marginal zone, the occurrence of the lower zone in sill-like bodies, and a critical zone correlative that instead of the more stratiform chromatites that we've previously shown, we see more contact styles of mineralization. So we made 3 main visits over a period of 5 days, starting here in the southeast, looking at the Maasfontein kimberlite. We moved further north to look at the Platte Reef and visit facilities of Terra Platinum. And we finished the trip with a visit to the Zarplatz tin field. So just briefly on kimberlites. Kimberlites are porphyritic ultramafic volcanic breccias that form from mantle-derived melts that as they ascend, they can incorporate some diamond xenocrysts, forming these diamondiferous kimberlite deposits. They often form these pipe-like structures, and they are divided into group 1 and group 2 kimberlites. So common indicator minerals, kimberlite indicator minerals include chromium diopside, pyrope garnet, spinel, and so we visited the Maasfontein kimberlite led by Mr. James Campbell, who's a renowned geologist with approximately 40 years of experience in diamond exploration and diamond mining. So the kimberlite we visited was approximately 155 million years old, and it is a group 2 kimberlite. So it is ultra-potassic. So it represents the blowout zone, as seen here, of a typical kimberlite pipe, and it is related to other dike swarms that come in for several kilometers. So its historic significance is that it was mined in joint venture by Southern Era and BS between 1999 and 2000. But what's remarkable is that it produced a payback time of the initial capital of 4 days, which is quite remarkable. So yeah, here's the kimberlite dike. We have Moano here for scale and Malefa here. So the kimberlite dike came through, cutting through some altered Archaean granites that are themselves cross-cut by Karoo dolerites and blew out in this zone here. So forming an approximately 400 meter blowout zone. It even had produced some yellow diamonds and green diamonds. So what's interesting is that it is hypothesized to have never reached surface and was trapped beneath the crust. So yeah, and then after very insightful discussions with Mr. Campbell, we went kimberlite, indicator minerals, and diamond hunting in an old stockpile. Unfortunately, no one found a diamond. This smiley face is here because PowerPoint couldn't let us put a frowny face. So just, yeah, so, and then we had group F presenting. They presented on the economic significance of kimberlites, which was quite an insightful presentation. So then we moved on to visit the Plat Reef and Valterra Platinum's various facilities. So just a few words on the Plat Reef. It is a lithologically variable unit, ranges from a few tens of meters in the north to to several hundred kilometers in the south. And it lies above Archaean granite footwall units and Transvaal supergroups footwall units. And it is mineralized in PGE, copper, and nickel. So rock types of the Plat Reef include norites, paraperoxenites, feldspathetic peroxenites, gabronorites, and granofelses, which is a local term for a weird mixed rock that we saw. So we first visited Tweefontein and then visited the Tukwing stream to just walk a stratigraphic profile through the Plat Reef. So here we are having very heated discussions on Tweefontein Hill, just discussing the various signs of magma emplacement that we've seen. These included overprinting of bedding and recrystallization of iron oxides forming hornfelses. And then we moved along the Tukwing stream, where we first saw a raft of calc silicates. Then we saw the norites, the pyroxenites, the gabronorites, and we finished the day off with a presentation by Group E on PGE deposits in the northern limb. So the next day, we visited Valterra Platinum's Northern Limb Regional Exploration Geology Courtyard. Here's where Valterra Platinum stores all historic exploration core and current projects for logging, analysis, sampling, and the likes. So we started with an induction, and we had interesting discussions on the exploration chain from drilling, sampling, modeling, all the likes. And then they showed us their facilities, their main core shed where they log. So we also got to have a logging exercise, which, yeah, hey, and then, but which was quite cool as well. But we also got to see the signs of mineralization. So as you see here, we have a net textured sulfide. So it was quite cool to see these evidences of mineralization in person. And then the next day, we visited Valterra Platinum's Mogalakwena mine. It's a massive open pit operation and one of Valterra Platinum's flagship mines in the north. So yeah, here all protocols observed. As you know, on the mines, prior to entering, you have to do breathalyzer tests and everything to see if anyone's still in party mode or weekend mode. But we were all work, so we just flew through and then went in to have our induction and a few discussions with the team at Mogalakwena. So they took us through all their operations and they gave us details about the reef, and we got to next visit an open pit. So yeah, this was our visit to Mogalakwena South Pit, where they employ truck and shovel mining. So here, just to denote, the reef in this section was a few tens of meters in thickness, with the footwall of Archaean granite and hanging wall main zone. So the main takeaway that we saw from visiting the pit is, in order to extract these tens of meters of reef, they have to cut back all of this main zone material in order to extract tens of meters of reef. So it's quite a lot of waste that they have to extract. So it was quite cool to see these dynamics, and then they were able to explain this is why they are looking to transition more into underground mining. So we're exposed to the various ins and outs that goes into these various forms of mining. And then we visited a live drill rig while we were there, further up north, where they were drilling through main zone material. When we got there, they were at approximately 591 meters. So we got to see them actually pull out some of the reef, which was quite cool. And for many of us, it was our first time visiting a drill rig. So it was quite cool. We finished off visiting the Zyplatz tin deposit. These are hosted in the Leboa granite suite, which is the largest egg-type magma granitic body. So what we have in the Zyplatz tin field is magmatic hydrothermal mineralization in more endogranitic styles. We have they're mainly mining for tin and fluorine. So we mainly looked at the Boveyankop and Lis granites. These are altered granites, and they host the main mineralization, which occurs as disseminated Vagi styles and also through these hydrothermal pipes that are zoned. So here's just a few photos of the vaggy styles of mineralization. This is the main ore here of tin, the cassiterite. And here we have some fluorite as well, which is the main ore that they mine for the fluorine. What was interesting that we got to discuss is how the least granite, which lies at the top of the system, is finer grained, while the Obejankop, which lies below it, is coarse grained. So we finished the day having just discussions on those, the different processes that occur in endogranitic systems. And then we also had the presentation by Group F, who presented on the petrogenesis of granites in the Bushveld complex.
In conclusion, we have that Barberton Greenstone belt shows more Archaean tectonics and gold mineralization, while the Bushveld complex exhibits more stable tectonic regime, chromium PGE and nickel mineralization, tin and fluoride mineralization. So overall, the tectonics and crustal evolution from the Archaean to the Proterozoic in South Africa had a great influence on the metallogenesis. So there are different mineralization in the Archaean and the Proterozoic as seen preserved in the Barberton Greenstone belt and the Bushveld complex. We give a massive thank you to our lecturers, our demonstrators, and our class for helping us compile the presentation. So to show the lighthearted side of the learning, here is a 2-minute video for your amusement.
Okay, thank you guys. That was really incredible. Great presentation. So now we have time for some questions. You would like questions? Sure, you would like questions. Beautiful. No questions, right? Are there no questions from the audience, from the students? Loudly, loudly. Give me the microphone. I don't think that's one that's actually working.
Just noticed something I found that was the bio-oxidation to get gold extraction. Can you tell me more about that, please?
Yeah, sure. So biox is a metallurgical process. So this is post-mining everything. So it's literally they first float the material, then they take that floated material, put it in these biox tanks, and in these biox tanks there are cultures of bacteria that like to eat sulfides and basically get rid of all the gunk and basically leave most of the gold behind. And then following this, it goes to smelting and yeah.
Thank you.
Okay. I think that'll work, Robin, right? Good. Okay, so any other questions from anyone else in the room? I've got a quick question, a pre-prepared or a question that came up as you were talking. Do you have any, you saw mineralization in the Bushveld complex in the eastern limb and the northern limb. Did you have any vigorous debates about what causes the difference in PGE mineralization between the eastern limb and the northern limb? Any ideas or thoughts about that? You can talk into that microphone there.
Yes. So some of the ideas, and as part of the course content, we actually had with Dr. McLaren paper on the platinum, so which discussed how the pre-existing structures, it was quite heavily deformed. So the structures were hypothesized to be a reason why it was more of mineralization versus the more stratiform style. So probably in the eastern and western limbs, those pre-existing structures didn't maybe force the magma to be isolated in certain zone and behave in certain ways to promote, so that they had more time to fractionate and produce these stratiform reefs. So in the northern limb, it was more contact, and the footwalls are very sulfur rich, so they promoted early sulfur saturation to form these deposits.
Right. Okay. Any other questions?
I happen to hear you saying that the wavy chromite layers. I'm just a little bit curious as to, having you guys said that it was a little bit odd for you guys finding them being wavy. I'm just now curious as to, like, okay, so what was the reasoning behind them? What is the key underlying thing behind how they were wavy? Is it the accompanying layers, or maybe the deposition of the layers that caused them to, I'm just curious as to, yeah. Yeah.
Oh. Yeah, I'm not sure I can properly answer your question, but so usually we see these stratiform chromatite layers, like the LG6 chromatite. It's pretty flat throughout the Bushveld. And as soon as we go to this UG1 chromatite, it's a bit wavy. It might have to be, it might have to do with what cumulates were forming at the time. So certain cumulates were more easily eroded by thermal or chemical erosion, or yeah. But I think I'll get back to you on that one.
Okay. Any other questions? I don't think we have any questions online. We can just quickly check. Oh gosh, we're in for some questions online. Well done. Yes, we can echo that. Okay, that's fine. Right, if you can answer this question from Gillian. Does the underlying rock or footwall affect mineralization? I don't know where, actually. Maybe in the, I'm not sure where Jill's talking about. In the northern. Does the footwall affect mineralization in the northern limb? Do you see differences along strike where there's different footwalls?
Oh, yes, yes. What we actually saw, I'm not sure if, oh, yes. What we actually saw, I'm not sure if I can move back now. I'll try to. But yes, but in the north, the reef is quite thinner. It's a few tens of meters, while in the south it's more, it's quite thicker. Not to keep going.
Yeah.
Yes. So we actually had a discussion with the lecturers, and various ideas were discussed as to why perhaps here in the northwards the Archaean granites it's much thinner, whereas in the southwards the Transvaal sequences it's much more thicker. So a hypothesis was in the south these magmas also infiltrated into bedding plains and the likes. So while they were dissolving this material, some of these maybe calcilicates, those remnants would be left, forming a thicker reef package. Whereas in the north, the granites would be more massive and it would be harder to infiltrate within. So it forms these granophyles, which are mixed. It's partial melting of the granites, and they mix with these plate reef magmas.
All right, on that point, I think, I don't think you can open the chat and see if there's another question there. Just click on it. Go down.
Please repeat the questions, correct?
Okay, that's fine. We got that. Oh, that's a good question. What causes the potholes in the Bushveld complex? In the geology, not the roads. You have to speak loudly and into this microphone. Speak loudly so the whole class can hear you and the people online.
Oh, so basically with the potholes that they observe in different mines in the Bushveld is that there are actually, I think, 3 models that they use to explain those potholes. One of them being geochemical erosion. Basically, when the fluids, when they intrude, they erode the surface they intrude on. The other one was sagging, whereby the softer material will just sag down, then it forms those potholes you see there. And the other one is basically one of the tectonic, the rifting. Is it rifting? Yeah, when they move apart. That's the other third model that they use to explain potholes.
Okay, good. Thank you, everyone. Thank you, guys, for that fantastic presentation. Really, really good. Congratulations to the whole class. I think you did really good. And I also think it's appropriate to acknowledge several people as well. Obviously, the presenters, the whole class for putting this together, but I think we also have to acknowledge the minds that hosted the students. It's not easy to host so many students, and they go out of their way to really show you a good time and also show you good geology. So I think it's very important to thank those minds. You saw many of them, and also to thank the team that went along and organized the trip. Ben, Linda, Leo, Fumi, and Daniel, I think, with the team. And as you know, it's a lot of hard work. So you've organized a fantastic trip, and I'm sure the class is very grateful. So another round of applause for them. And Ben and Robin can correct me if I'm wrong, but I think that James Campbell is presenting next week, the 7th of August. Okay, next week we have a Geotalk by Cameron Penn Clark, which will be interesting, and a shift of focus to, I presume, sedimentology. And then James Campbell, who you guys spoke about earlier, is coming the week after. So it'll be a chance for all the other students, if you want to network with someone like James Campbell.
Who's James Campbell?
He was in the presentation. Mars Fontaine.
All right.
All right, thank you, everyone, and thank you, guys.
Hallelujah.